Okay, so it's pretty easy to do most of these problems. Till you get over to this one, I'm just using this one to demonstrate why it is you want to follow a very specific procedure when you do this. Okay? And I showed you the specific. Some mornings I can talk and sometimes I can't. I really can't say specific. Something sticking in there. Okay. Okay, so we have 5/8 plus 7/12. What do you think when you see this? You think if I've got a bunch of apples and divide them all into, or divide one into 8 pieces and one into 12 pieces, and then I take 5 of those and try to add it to 7 of those, it doesn't work. Okay? They have to be divided into more pieces. Now, let's skip to the third problem, one with the biggest numbers in it. That one you can do. You can take an object, whatever it is, and cut it up into 173 equal pieces. You can do that. I don't know. I don't want to try to cut something into 173 equal pieces, but you can imagine that. Then you take 5 of them, and then you take 9 of them, and what do you have? You have 14 of them, right? And each of those pieces is 173rd of the whole. So you're adding 5 of those pieces to 9 of those pieces, you're going to get 14 of those pieces. Now, the rule is you add the numerators if you have the same denominator, and you don't add the denominators. By putting those pieces together, you didn't all of a sudden create something with 346 pieces, which is what you'd get if you added these. Okay? You want to think about what it means. So now I need to be in the habit of saying, okay, 5 over 173 plus 9 over 173. That's the problem. I need to read the problem because playing around with AI, I found that it can do some really good stuff in summarizing what I'm saying. It appears to understand what I'm talking about, even if there are transcription difficulties. Even if I garble some of my words, it can figure out what I'm saying and do a really nice summary, really nice representation. And I want to get in the habit of putting those representations up there. It can also put this into screen readable format, which I need to do for ADA compliance. And that's all very simple. I just clearly define what I want it to do. I see that it does something that doesn't quite represent what I was saying. You know, I did this with my pre-calculus class, you know, the transcript. And it did a couple of bonehead things. So you got to keep an eye on it. But it does come up very nicely organized summary. So I'm going to read these things very pedantically. Okay. And I'm trying to get myself in the habit of doing that because I'm used to just pointing this and this, assuming people can see. And since not everybody can see, among my distance students, some of them might have sight problems that are like my hearing problems. And I forgot my hearing aids today, but just talk a little louder. Hearing loss isn't that bad, but if you talk real soft from the corner of the room, I'm not going to understand you. I might not even hear the noise. Okay, let's go back to the math now. Okay, so we started with, I could read it 5/173 plus 9/173. 2 fractions needed to be added. Each of these fractions has the same denominator, so you can imagine cutting something into 173 pieces, putting 5 of them over here and 9 of them over there, and then saying, well, how many of them do I have? Well, you know, you got 14 of them, and you still have a 14 173rds, 14 out of 173 pieces. Okay, so you really, really, really want to understand that, understand fractions. All right, now let's go up to 5/8 plus 7/12. Now that is read 5/8 plus 7/12. Although if I say 5/8 plus 7/12, AI will interpret that and write it with slashes if I ask it to. But anyhow, 5/8 plus 7/12, but I'll also read it 5/8 plus 7/12. How do we do that? The denominators are 8 and 12. They're different. Okay. So if we cut one thing into 8 pieces and another thing into 12 pieces and put those together, we still don't know just what fraction of a whole we have. So we have to get a common denominator, and I think everybody recognizes that. Showed you earlier how to do a common denominator. Can you do prime factorization of 8? Did you pick up on that in class? Did Open Math mention prime factorization? Probably should have in the second assignment. Okay. So, common denominator. What is the common denominator? Well, if you take 8, 2 divides 8. So 8 is 2 times 4. And 2 divides 4. So 8 is 2 times 2 times 2. 12 is 2 times 6, which is 2 times 2 times 3. It's very easy to do this. Now, if you get a number like 731, I can figure it out in my head because biggest number you'd have to divide by to get that is probably about 20. And you wouldn't have to divide by 29, 23 probably. Okay. You'd have to divide by numbers up to 23 if that one was prime to determine that it is. I just mentioned that. But for the problems we're working on here, if you can divide by 2, 3, 5, and 7, and maybe 11, you're probably okay. So pick up on the prime factorization. Now, what is the common denominator? Common denominator, well, you have to have, just pick one of them, you write the whole thing out. Common denominator has to have 2 times 2 times 2, or it won't have 8 in it. Okay? Is there anything else it needs? Well, it needs a 2 and a 2, but it's already got 3 2s, so it doesn't need any more. It only needs 2 of them to make up this number, and then it needs 3. That turns out to be 24. So now we can write 5/8 multiplied by 3/3. 5/8 times 3/3. It's still equal to 5/8 because 3/3 is just equal to 1. And when you multiply by 1, you don't change the value, you just change the way it's represented. So we write this step out. Okay. And one thing I think I tried to emphasize last time is you want to write out every step the way I did it. Okay. It's not that there's anything wrong with the way you're doing it, except that the way everybody's doing it is getting correct solution for the most part. Okay. And a lot of times it's written down pretty coherently. Sometimes it's scattered a little bit on the page. And you really don't want that because it gets confusing. It confuses you. It doesn't confuse me. I can find it. It confuses you. Don't confuse yourself. Keep things organized. Okay, so it's 5/8 times 3/3. There you got your 5/8. And then your 7/12 you got to get a denominator of 24. So you're going to have to multiply 12 by 2. Multiplying the 12 by 2, well, you better multiply the numerator by 2 as well, right? So we multiply by 2 over 2. I'm going to run out of room here. This gives me 15 over 24 plus 14 over 24, which equals 29 over 24. Okay? I really want to see this step. And let me explain why. Later on, you're going to have to add something like this. Okay? If you know what you're doing here, and if you're used to writing out all these steps, it's not that difficult. I'm going to do it. You don't have to understand this. It's not going to be in a test anytime soon. Okay? But I want to demonstrate the reason that I'm asking you to do this in a very specific form, because you're going to want that specific form when you encounter this. But the form is very much the same. Okay, right here, we have our first term. Now, the expression is this. First fractional expression has a numerator of x times the quantity x plus 2 quantity. Okay? Denominator, x minus quantity x minus 3 quantity times a quantity x plus 5 quantity. I could say that then in shorthand notation, x times a quantity x plus 2, pause so you know the quantity's over, and then over x minus 3, x plus 5. But I want to say it as completely as possible. Okay, so anyhow, here is the thing. The other one has a numerator of 2x squared minus 4. So I'm going to write that down here, 2x squared minus 4. Denominator is a quantity x plus 3 quantity times a quantity x plus 5 quantity. You have to say the quantity twice so that you know when the quantity ends. You know, it tells you where the parentheses are. Okay. Now, anybody want to make a guess what the common denominator would be? Okay, so our denominators has this, the first denominator has factors quantity x minus 3 quantity x plus 5 quantity x plus 3 in the second expression is in the denominator, and quantity x plus 5. So we've got to have the x minus 3, the x plus 5, the x plus 3, and the x plus 5, right? But we don't have to have the x plus 5 twice. If it's there in the denominator, it's there. Okay? So the common denominator is x minus 3 times x plus 3 times x plus 5. Now, we don't want to take too much time on this. I'll just proceed. What are we missing in this denominator then in order to get the common denominator? The first denominator has the quantity x minus 3 and the quantity x plus 5. What's missing? Well, it doesn't have an x plus 3, does it? Look at this, look at this. This needs an x plus 3 for these two to have the same denominator. And when they have the same denominator, you're going to be able to add them. So how do you do that? You really want to write it out. X plus 3 over x plus 3. Now, assuming we're adding these, I never did put a plus sign in there. We do the same thing over here. We see what the common denominator has that this one doesn't, because we want to build this up into its common denominator. And that's going to be the x minus 3. So we multiply this by x minus 3 over x minus 3. Specifically, we multiply the second fractional or rational quantity. And now you see that the denominators are both going to come out the same. You have to multiply the numerators, and that gets a little messy. You got to use a distributive law and stuff. We're not going to go there right now. But once you've got it written down here, there are a couple of simple laws that you won't have much trouble with, and you'll be able to add this thing. Okay? So when you get there, you want to be in the habit of writing out the step where you multiply. Okay, with the 5/8, you multiply by the 3 over 3. With the 7/12, you multiply by the 2 over 2. Don't skip that step. You want to be in the habit of doing that step so you'll know exactly what you're going to need to do when you get here and not have to learn it from scratch. Does that make sense? And most of the things that we do for the first month here are going to be things that you need to build on, and you're not going to need to do them in a very specific, very coherent, and very organized way. Okay? So in your notebook, and I hope you're writing these things down in a dedicated notebook so I can look at how things are being structured. Then I can come around and say, yeah, that's a good solution. But you skip this step because you know how to do it already. Okay? Makes sense? And I can just give you advice. I can say, yeah, it's a little bit scattered. It'd be better if this is in columns. Okay? And you're going to ignore me for the first 3 or 4 times, but eventually you might catch on. And then you're going to be able to do the mathematics much more easily because you're not making it harder on yourself by some scattered form. Now, different people will have different preferred forms. The form I tell you is not necessarily the form you prefer. Use the form I give you. Once you got that mastered, use whatever form works best for you. But use a form that you're going to be able to use for review. If something's scattered all over the page and you haven't looked at it for a month, you're not going to be able to see it. I mean, you will because you've done it, but it's going to take you a while. Whereas if you got it in an organized fashion, it's going to be there for you. Okay. All right. Well, let's look at some other problems, but they all follow the same general idea. Just kind of hoping to keep this up here. Hang on a minute. Rearrange these boards a little. Okay. Now let's take the second problem. I'll just read it. 3/7 minus 5/9. I wrote it without the slashes, but I'm reading it with the slashes. It's just 3/7 minus 5/9. Okay. What else? You need a common denominator, right? So find a common denominator. Now I'm going to do that over here. Seven is prime because if nothing divides into 7 evenly. Okay. You try 2, 2 doesn't go into 7, 3 doesn't go into 7, 5 doesn't go into 7. You wouldn't even try 4 since 2 didn't go in, 4 wouldn't. And now you're going to try 6 because you've tried both 2 and 3. Okay. 7 is prime. You can't divide 9 by 2, so you go to the next prime number and you divide by 3, and it does divide 9. It's 3 times 3. So it's pretty clear that your common denominator is 7 times 3 times 3. Now you see, open math, sometimes we'll write 7 times 3 squared. Pretty common, but right now I'm not going to assume that you're all that tuned into exponents, although I think you probably are. Just write out all the factors. Now, if you get 1024, that's 2 times 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 2. And that's where you start, write it as 2 to the 10th exponents. I prefer just to write out all the factors at this point. All right, so I'm going to put this in columns. So over here, I've got my side calculation, and probably shouldn't put the equal sign there. Put the equal sign down on the next line. And my 3/7, in order to get the common denominator, need a couple of 3s, doesn't it? So I'm going to write all the factors very explicitly. It's 3/7, and then to get a denominator 7 times 3 times 3, I got to multiply the denominator 7 by 3 times 3. Of course, that's 9, and that would be okay, but I'm going to just write 3 times 3. If I multiply the denominator by 3 times 3, I've got to multiply the numerator by 3 times 3, so that I'm ultimately multiplying the fraction 3/7 by 3 times 3 over 3 times 3, and that's just 1. This doesn't change the value of the fraction. Then we have minus 5 over 9, and we've got to multiply that by 7 over 7. Now, I could have written the 9 as 3 times 3, but we kind of implicitly know that. So when we look at 5 9s, we want a denominator 7 times 3 times 3. The 9 is the 3 times 3, and we multiply by 7 over 7. So this comes out 3 times 3 times 3 minus 5 times 7 over 7 times 3 times 3. Okay. And now at this stage, I multiply it out. 3 times 3 times 3 is 27. 5 times 7 is 35. And 7 times 3 times 3 is 63. Then I can simplify the numerator, okay? So I've got numerator 27 minus 35, denominator 63. Add up everything in the numerator. And of course, if I've got a minus sign, it's like adding a negative, it's like subtracting. So when I say I add up the numerator, I'm adding 27 and negative 35 to get negative 8. And then that doesn't reduce. I recommend you write out all the steps like this and shortcut as little as possible when you do these short assignments, because these are short assignments. Okay. Doesn't mean it won't take you a long time if you have a lot of trouble with fractions. Write it out in detail. If you're not getting it, have it in your notebook. Show me next time. Or use your phone. If you have a scanner app on your phone, scan it. Email me a PDF. Okay. I'll be glad to respond. All right. Now, moving on. We've got these problems, which I regard as optional. I wouldn't grade these. It's kind of new stuff. Let's see what I can do with these. Probably collapse the whole thing. It's not wanting to work. Well, I'll do it anyway. Okay, so we've got a problem that has 5/8, 5/8 plus 2/3, 2/3 multiplied by 1/6. 5/8 plus 2/3 times 1/6. What's that equal? Well, it's 5/8. We're not going to do anything to 5/8 because we know that we multiply before we add. Okay. We're not going to add 5/8 to 2/3. We're going to multiply the 2/3 times the 1/6. Okay. Always. Addition and multiplication before, multiplication and division before addition and subtraction. Okay. Now that's the subject of the next assignment. It's just order of operations with fractions. And there are two assignments you'll have to do for next class. If we're in session for the next class, we're supposed to get a significant amount of snow this weekend, and then it's going to be cold all week. I think the night before class, it sounds, right now the forecast is 2 degrees. So don't know how long it's going to take the roads to get clear. Snow might not materialize, or it might be even worse than they say. We just give up and all go live in caves. Okay. Any case, this is going to be due next week. Okay. Along with one where you just do it with numbers without fractions. Okay. 5/8. Then we have to multiply the 2/3 by the 1/6, the 2/3 times the 1/6. And that's going to be, now there are shortcuts you can take. You can divide the 2 into the 6 and all that stuff. Not going to do that. You can use those shortcuts when you see the form of the problem. Okay. So this means you multiply the numerators, you multiply the denominators. If you're adding things, you can't add the denominators. You don't add denominators on an addition or subtraction. Okay. When you multiply the numerators and you multiply the denominators. So we have 5/8 plus 2 times 1 slash 3 times 6, which is 5/8 plus 2/12. Now at this stage, you do want to reduce this fraction. I believe everybody knows. I'm going to write it out in detail.
Is it 2/12 or 2/18?
I got the 2 in my head. I just kept it while I was supposed to be multiplying 3 by 6. So in the third step, after 5/8 plus 2 times 1 over 3 times 6, should have had 2 over 18. Thank you. Keep an eye on me. I do those things. Okay. Well, actually, I know what. Okay. Okay, so my 2 over 18 could be written as 2 over 2 times 9. And again, I'm doing this step not because I don't think you can divide both numerator and denominator by 2, but because when you get into the symbol thing with all the x's like we saw before, you're going to have to do some factoring there. And just wanted to get used to the idea. So I prefer you would write this in this form. And then if 2 is a factor of the denominator and a factor of the numerator, and by factor, I mean something that's multiplied by everything else. That's what a factor is. One of the things AI did is talking about exponents. And so when you multiply an x times x by x times x times x, you concatenate the factors. That was in their summary. And as I do a summary, for students whose background is shaky, okay? And I had to tell it, concatenate factors. Most students don't have the word concatenate in their vocabulary and aren't clear what factors are at this stage. So, you've got to watch AI. Okay, it's a little bit of a digression, but again, I want to emphasize 2 is a factor of the denominator because it's multiplied by the rest of the denominator, okay? You get the denominator by multiplying 2 by something else. And a 2 is in the numerator, so it is a factor of the numerator, so that we can actually just do 2 divided by 2. And we get 1 over 9. And some people say we cancel the 2's. Okay, you're probably used to that. You can only cancel factors of the numerator with factors of the denominator. People make mistakes with that rule. Anyhow, okay, 5/8 plus 8/9, your common denominator. Okay. 8 is 2 times 2 times 2. 9 is 3 times 3. And they have nothing in common. The common denominator is 2 times 2 times 2 times 3 times 3. And I'm going to write it that way. But I will mention that if you don't have any factors in common, you can just multiply the numerator and denominator, get a common denominator. Okay. So that's 5/8 times. What do you need to get this common denominator? 8 is, I'm going a little too far with this, but I'm going to do it anyway. Okay, here. I'm going to write 5/8 as 5 over 2 times 2 times 2. And I'm going to multiply that by 3 times 3 over 3 times 3, which gives us a numerator of 5 times 3 times 3. Denominator of 2 times 2 times 2 times 3 times 3. I don't have room to write my 1/9. I have to. It's 1 over 3 times 3 multiplied by 2 times 2 times 2 over 2 times 2 times 2. And then I can multiply it out. 5 times 3 times 3 is 45. 2 times 2 times 2 times 3 times 3 is 72. And then it's plus 2 times 2 times 2 times 1 is 8 over 72. And that equals 53 over 72. Nothing divides 53, so you can't reduce this. Now I'm going to do it shorter. Okay, this is what's really going on. You really want to understand it. You really want to try to write it out in the greatest possible detail. Now, if you got 100 problems, you're not going to want to do that. And you don't need to. If you've written it out for half a dozen or 10 problems, then you're probably going to understand it. Okay. Now I can also do that. Okay, 5/8 plus I'm not gonna go through the part of getting down to the 5/8 plus 1/9. I'll just start with the 5/8, 5/8 plus 1/9. And the common denominator, I can say there are no common factors. We don't have to do prime factorization. The common denominator is just 8 times 9, which is a lot easier to write than 2 times 2 times 2 times 3 times 3. Still, you want to try to do this. But the way you're ultimately going to do it is then you're going to just say, okay, 5/8. We need a common denominator of 8 times 9. So we have to multiply that by 9/9. And then 1/9 times 8/8 gives me a common denominator of 8 times 9, right? And that's 45/72 plus 8/72, which equals 53/72. And you want to see it like this as well. I recommend that you do it like this, then you do it a shorter way to see that they're the same. It gives you a better picture of the structure of the numbers. It emphasizes the fact that you want to look at the factors so that when you get into it with algebraic expressions, you'll know to do that. Okay. Now, we have another 3/4 times the quantity 7/8 minus 5/7. And there's an important rule that goes along with this one. So let's write this down. And then I'm going to get rid of this one board here. And pull this one over. So we're sure it's on camera. And I should have checked. I'm not sure that this last calculation was on the camera. So I'm just going to go over it very quickly again. We had the 5/8 plus 1/9. There are no common factors in the denominator. So the common denominator is 8 times 9. In order to get denominator of 9 with a 5/8, we multiply by 9/9, 9/9. So we multiply 5/8 by 9/9. And our denominator will be 8 times 9. Now our 1/9 that we're adding is going to multiply by 8/8. And the denominator will then be denominator 9 times denominator 8, which is also equal to our common denominator 8 times 9. Then we do the arithmetic. 5/8 times 9/9 is 5 times 9 is 45. 8 times 9 is 72. 1/9 times 8/8 is 1 times 8/9 times 8. 8/72. Same thing we had before. We add the numerators, keep the denominator 72, we get 53/72. Okay. Now we have 3/4, 3/4 times the quantity 7/8 minus 5/7 quantity. What do we do here? Well, this equals 3/4 times 7/8 minus 3/4 times 5/7. Why is that? Well, we're multiplying 3/4 by the quantity 7/8 minus 5/7, the quantity. That means a 3/4 multiplies a 7/8, and it multiplies the -5/7. And that's what we're saying here. It's called the distributive law of multiplication over addition. And I assume you're pretty well familiar with it, but just make sure that we really are familiar. Okay. Then it gets kind of easy for a minute because we multiply numerators and multiply denominators. We have two products. We have 3/4 multiplied by 7/8, and we have 3/4 multiplied by 5/7. So for the first one, 3/4 times 7/8, we multiply the numerators. 3 times 7 gives us 21. Denominators, 4 times 8 gives us 32. On the 3/4 times 5/7, multiply the numerators, 3 times 5, which is 15. Denominators, 4 times 7 is 28. And of course, that's minus because it's minus up here. Now we've got denominators of 32 and 28. Okay. So I'm going to go over here and do the common denominator. (32) is 2 to the 5th power. 2 times 2 times 2 times 2 times 2, or 2 to the 5th. And at this stage, it'd be some advantage to writing 2 to the 5th, but I'm going to keep it written out. But 28 is a little shorter. That's just 2 times 2 times 7. So the common denominator is just 2 times 2 times 2 times 2 times 2 times 7. It has everything either denominator has, and it has no more than necessary. Okay? That's why we call it the least common denominator. I say common denominator. This one is the least common denominator. Okay. Well, I'm going to bring this calculation up here so I have room. So this is going to equal 21 over all those 2's. I'll write the 32 in its factored form, multiplied by 7. I'll use parentheses for multiplication. It seems to get a little confusing here. Okay. So now we see the denominator is 2 to the 5th times 7. 2 times 2 times 2 times 2 times 2 times 7. Okay, multiplying by 7 over 7 is going to give us the common denominator. Then it's minus 15. And I'll write the denominator in factored form, 2 times 2 times 7. And then what am I going to multiply by? I'm going to multiply by everything else I need to get all these 2's. I need 3 more 2's here to get the same denominator that I have here. So I'm going to have to multiply by 2 times 2 times 2 over 2 times 2 times 2. Now saying that a little more clearly, by 15 over 28 is written in this step as 15 over 2 times 2 times 7, because 28 is 2 times 2 times 7. And then I want a denominator with 5 2's in it in a 7. I've already got 2 2's in a 7, so I just need 3 more. So I multiply by 2 times 2 times 2 over 2 times 2 times 2.
We're good. Yeah, we are. Yes. Congratulations.
Now this is going to come out 147 over 234, I think. Double check that. 7 times 32, that's 224. Then it's minus 120 over 224. In other words, I multiply out the numerator and the denominator. 21 times 7 gives me 147. The denominator, 2 times 2 times 2 times 2 times 2 times 7 gives me 224. And that takes care of my 21 over 32. It comes out 147 over 224. Similarly, the 15 over 28 comes out 120 over 224. And if my arithmetic is correct, then you can finish that easily. You're going to end up with 27 over 224, and that will reduce. And I'm not going to write down that step. Okay? Okay, now let's step away from fractions for a while. I know you hate to see them go. This thing has a nasty habit. It shows that it's recording if I hit the trackpad, and then it goes away. So I never know if it's recording or not. They need a better design team. They don't want me on it. They should take my advice, but they don't want me designing things. Okay, that would not be my forte. So I'm not throwing stones, thinking that I can do a better job than they do, but I can identify things that they really should have as features of their software. Okay, so let's take and everybody write that down and calculate it. Okay, the problem is 4/7 times 3 minus 5 times 2. The rule is you do additions or multiplications and divisions in order. So, for example, you would not multiply the 7 by the 3. You would first divide the 4 by the 7, which gives you 4/7. Now, I could have avoided fractions by making this something that divides out evenly, but I'm going to write it the way it is. It's 4/7. And that's times 3. And then 5 times 2 is 10. Now, what's 4/7 times 3? Well, we really haven't done we haven't formally done multiplication of fractions. We start with addition because we're reviewing, and later on we kind of clean up multiplication. If you haven't any trouble with multiplication of fractions, you can work ahead a couple of assignments and find it and work it if you like. It won't be important until a little bit later, but it's a good thing to get out of the way now. Okay, now just to be clear, 4/7 times 3, the rule is multiply numerators, multiply denominators. And there's no denominator on 3. But I can write 3 as 3/1, and now I have 2 numerators and 2 denominators, okay? And that's something I think people are pretty familiar with. So 4 times 3 is 12 over 7 minus 10.
So it's just a slim slide. Because.
And now I'm going to write it out without being real detailed about it. That's 12 over 7. I'm going to get a common denominator. 10 isn't a fraction, but I can write it as a fraction. And it needs to have a denominator 7. Well, you got 10 over 1, you got to multiply that by 7. You got to multiply the 1 by 7 to get 7 as your denominator. But here we have it. And let's make sure the board's visible all the way down. Okay. So we can write this 10 over 1 times 7 over 7. We multiply the numerators. 10 times 7 is 70. 1 times 7 is 7. So our 12 over 7 minus 10 over 1 times 7 over 7 becomes 12 over 7 minus 70 over 7. And then that's 12 minus 70 over 7, which is negative 58 over 7. And we're done. Because 7 does not divide into 58, it divides into 56, not 58.